Okay, here's how to simplify radicals. This video I'll just cover square roots. I won't cover cube roots or higher powered roots. So let's start with an example. Let's start with the square root of 4. Looking at the square root of 4, some people might know that the square root of 4 equals 2 automatically, but if you don't worry. We can ask ourselves, what number multiplies by itself to equal 4? And we know that 4 equals 2 times 2, which is equal to 2 squared. So that means the square root of 4 is equal to the square root of 2 times 2, which is equal to the square root of 2 squared, which is equal to 2. Another example is the square root of 9. So we ask ourselves again, what number multiplies by itself to equal 9? 3 times 3 is equal to 9, which is the same as 3 squared. So we have the square root of 9 is equal to the square root of 3 times 3, which is equal to the square root of 3 squared, which is equal to 9. These two numbers are called perfect squares. 4 and 9 are perfect squares. A perfect square is when is the result of is a number that is when you take a square root is a whole number. If we look at something like the square root of 8, this is not a perfect square. So we have to ask ourselves, what is the prime factorization of 8? Or, if you don't remember prime factorization, which I'll go over briefly in a minute, or you can ask yourself, what prime numbers can I multiply to get 8? So if you look at 8, if I take a 2 out, 8 divided by 2 is 4, and then 4 divided by 2 is 2. So the prime factorization of 8, the square root of 8, is equal to 2 times 2 times 2, which is equal to 2 squared times 2, which is equal to the square root of 2 times the square root of 2. The square root of 4 times the square root of 2, which is equal to, we already dealt with the square root of 4 up here, and we said the square root of 4 is equal to 2, so this is equal to 2 square root 2. Now, another way you could look at this is some people notice immediately that the square root of 8 is equal to the square root of 4 times 2. If you could find a number, a prime number, that you can multiply by another number, so 4 is, not prime, a perfect square. So 4 is the highest perfect square that we can multiply by any number to get 8. because then once you have a perfect square under the square root, you have the square root of 4 times the square root of 2 is equal to 2 radical 2. So if you know that you have a perfect square being multiplied by a number in order to get the number in question, in this case it was 8, then you can go ahead and simplify that way. But we'll do a couple other examples just to help to make sure you understand when the number. Here with square root of 4, square root of 9, and square root of 8, and we could write it all out like this, or a little bit tougher. So the next example we'll do is the square root of 48. So we ask ourselves, what prime numbers multiply to 48? Or you can ask yourself, what perfect square evenly divides 48? So, if you're not comfortable with what numbers are perfect squares, or you can't think of, the highest perfect square that would evenly divide 48, we can start with the factor tree again. So 48, I pull a 2 out of 48 and I get 24. If I divide 24 by 2, I get 12. 12 by 2, I get 6. 6 by 2, I get 3. Now, we can go through the same process that we did with, once we have our prime factor tree, since we're taking the square root, I'll circle all my pairs of the same number. So then I know that the square root of 48 is equal to 2 times 2 times the square root of 3. When you pair up your 2's, these 2's, you have 2 times 2, so when you take the square root of 2 times 2, you end up with 2, and same thing here. So that's why we have 2 times 2, and then the 3 does not have a pair, so it stays inside my square root. So this leaves me with the final answer of 4 square root 3. Now, if you knew the perfect square (16) multiplied by 3 is equal to 48, then you can complete the problem this way. If you know that the square root of 48 is equal to square root of 16 times 3, where 16 is the highest perfect square that evenly divides 48, then we know that the square root of 16 times the square root of 3 is equal to 4 square root 3. So there's two ways to go about this problem based on your how comfortable you are with perfect squares. But if you ever get a really big number and you don't know the perfect square, or you're taking an exam and have a mind blank, go ahead and look at your factor tree and you'll get the same answer. So we'll do one more example. The square root of 75. Okay, so we ask ourselves the same questions. What prime numbers multiply to 75, and what, or I should say, or you could ask this question, what is the greatest perfect square that evenly divides 75? Okay. I'll do the factor tree way first. So we have 75. You can't pull a 2 evenly out of 75. You can't pull a 3 evenly out of 75. 4 is not a prime number, but we can pull a 5 out of 75. And a 25 is left. And then 25, again, you can't pull a 2 or a 3 out of 25. 4 is not a prime number, but we can divide it by 5, and we end up with 5. We circle our pairs. We have one pair of 5 and one left. I'm sorry. I just messed up. Thinking too fast. Okay. I can pull a 3 out of 75. A 3 out of 75, and I'm left with 25. And now I could pull a 5 and a 5 out, and we're left with the 2 5s. So now we know immediately that the square root of 75 is equal to 5 square root 3. Again, my pair of 5s ends up just being 5 there, and my 3 stays inside my radical, my square root. If you knew or recognized that 75 is equal to 25 times 3, then you might solve the problem this way. Square root of 75 is equal to square root of 25 times 3, which is equal to the square root of 25 times the square root of 3. Square root of 25 is 5 times the square root of 3. So there's two different ways, again, for you to simplify radicals with a square root. And I hoped this video helped.